afternoon, everyone, and welcome to another episode of MSME Masterclass. Today, we have with us a leader who has spent nearly 3 decades working at the heart of heavy industrial machinery reliability. Please join me in welcoming Mr. Uday Purohit, founder and CEO of Neptunus Power Plant Services Limited, Private Limited. Mr. Purohit leads a company that specializes in major rebuilds of diesel engines and propulsion systems for marine and industrial fleets worldwide. In India, Neptunus represents global technology leaders like IHI and EMD, supporting operators with overhaul execution, engineering upgrades, and commissioning of mission-critical equipments. What makes his perspective especially valuable for our MSME audience is his deep experience in lifecycle management, not just installing machinery, but also ensuring its reliability, availability, and cost efficiency over time. From rebuilding heavy engines to introducing electric propulsion systems for next generation tugboats, his work revolves around preventing failures before they become costly disruptions. In today's session, he will help us understand how MSMEs can prevent breakdowns in industrial machinery through better maintenance discipline, smarter upgrades, and practical reliability strategies that improve uptime and protect margins. Mr. Purohit, we're delighted to have you with us. Welcome to the MSME Masterclass.
Thank you, Amrita, and thank you for the introduction. Just one small correction. This November, I will complete 46 years in the industry.
Wow, so that's nearly 4 decades of working at the heart of industrial machinery systems. Lovely, sir. So we'll begin our session today with the first question. When we talk about machinery breakdowns, what are the most common root causes you see in MSME plants?
So in general, machines don't just break down. They give you warning signals. You'll see small changes in behavior. And once these are ignored, you can see performance deteriorating over a period of time, functional failure occurs, and then catastrophic failure. So really, it's lack of attention to detail. That's number one. The second thing to watch out is once an equipment has been under maintenance, that means people have worked on it, the chances of failure are the highest in the first few hours of operation. So for the first 200 hours of operation, after a machine has been touched by human beings for maintenance, is the time that is most critical. So that needs to be looked at very carefully. If you see the bathtub curve, you'll see that research has proved that the first 200, 300 hours after service, critical. And finally, simple things like bad lubrication, misalignment, etc., cause failures. So generally, this is the trend that I have seen over the past several years.
Uday, also tell us, why do small and mid-sized factories often experience repeated failures in the same machines?
See, if you do the same thing again and again, you'll get the same results. So a failure, and I'm going to repeat this several times, a failure or a breakdown is an opportunity for the organization to learn. If you don't do a root cause analysis and if you don't correct the cause, what you're simply doing is replacing a part, subjecting it to the same environment, and therefore it is no surprise that you're going to have a similar failure in the same time period. So same thing done again and again, same result. Failure and root cause analysis is something that is missing. And please, I don't blame the MSME owner. We'll talk about that a little bit more, but he has got limited bandwidth, and therefore his attention really is never down to what caused it. His attention is let's fix it and move on.
Got it. And at what point, Uday, does poor maintenance start becoming a business risk rather than just a technical issue?
See, an unreliable machine or equipment, when failures happen frequently and at random, when your customer requirements are not met, dispatch schedules are affected. That is the time that it's no more a technical issue. It is no more a shop floor issue. It becomes now a boardroom issue. But there is a more compelling reason why SME owners need to pay attention to this. You look at a typical MSME. We are squeezed by our customers. We are pushed by our vendors. Banks and government intrinsically do not trust us no matter what they say in public. So our interest rates are higher. They put us under scrutiny. And talent is always a crunch. So you look at all this, and there is just not enough bandwidth for the owner to look at growth, to look at expansion, etc. And so my appeal is that at least let's get this maintenance and breakdown issues out of the way. That will at least give you more bandwidth to do what you need to do. And I always say that the only cure for MSME ills is to get out of the orbit of becoming an MSME and become a larger organization. So that really is what the true issue is.
Understood. Also tell us, how can MSMEs differentiate between normal wear and early warning signs of failure?
So wear and tear is a normal phenomenon. So one way that you can do is track running hours. So if you know that a bearing will last for 8,000 hours, once you start getting warning signals, you know that this is normal wear and tear. So you can act on it. Hopefully you've planned in advance. Hopefully you've got the spare parts here. So normal wear and tear is something that every machine undergoes. What really should worry you is when the expected running hours are not met and failures occur before that. So when you talk of early warning, when you talk of warning signs, you need to understand, is this normal wear and tear? Have my running hours come to the useful residual life of the equipment? Or is this something that is unexpected? When it's unexpected, it's time to now take action and do a root cause analysis.
Also help our MSME attendees understand what are the biggest maintenance mistakes that are happening on the shop floor.
I've seen this in almost every organization that we visit. The number one cause is hygiene. And I say this again and again. See, we are a dusty country. So dust is there everywhere. It is a task to keep it out of our shop floors. Dust can be extremely extreme. It can cause extreme damage to equipment, to lubrication, etc. So I say that having people ask me, what is the best way to maintain your equipment? And I joke and say, get yourself the best possible industrial vacuum cleaner and keep your premises clean. So more than that, ignoring warning signals. Every machine gives you a warning signal. You're ignoring that. Lubrication becomes a very big issue. So people believe that putting in a lot of grease in a machine is okay. You're protecting the machine. What we don't realize is over-greasing is as harmful as no grease. Extra grease is causing overheating and all the other problems. So lubrication is one. Running until a machine breaks down. I've already covered that under big signs. Just one second. Sorry. Sorry, Amrita. So I've said that. Then lack of maintenance records becomes another big issue. People don't really know what has happened, why it has happened. There is always tribal knowledge. So some guy knows what is wrong with this machine, why it fails. He leaves the company, and then there is no question of a trend monitoring. So these are some of the issues. But I want to close this once again by saying hygiene is the principal issue that we need to look at in maintaining our equipment.
Now, talking about lubrication discipline, can you tell us how important it is in preventing premature equipment failures?
I have proved, and we have done this in several industries, that if you can keep your oil clean, you can increase equipment life by at least 3x times. And this is not, we've got data from several industries. So let me start with oil. Use the correct grade of oil, number one. Number two, the biggest mistake we all make is to believe that oil, sealed oil in a can or in a drum is clean oil. That is not the case. It is filled in industrial facilities where there is dirt and muck inside the oil. So please do not believe that sealed oil in a drum is clean oil. It is not. Please take simple steps like putting it through a filtration system before putting oil in your machine. Use kidney lube filters. The benefit of using kidney lube filters is so immense. In any machine that has more than 5 or 7 or 10 liters of oil, use kidney lube filters. 3x times you will prevent breakdown and increase life. Use the right quality of grease. You know, one of the most astonishing things I see when I go into industries, and big ones as well, is how oil is stored. So oil drums are stored amongst dirt, there's a muck around it. The oil pump which you use to fill up oil in the equipment is in dirt. You're putting all this dirt into a machine and then we wonder why it has failed. So once again, most of these are related to simple things like keeping oil clean, keeping the system free in hydraulic systems. Literally, you can avoid all maintenance if your oil is clean. And we have done this on ships, we've done this on small industries, we've done this on extrusion machines, we've done it in several instances. And I can say it with certainty that if you take care of your oil, just like your blood, if you take care of your blood and your blood is in this, that is a sign of good health. So that's the importance of lubrication discipline.
Now, they're talking about the ABC of shutdowns, which is alignment, balancing, and calibration. Can you tell us what role do they play in avoiding unexpected shutdowns?
So all these three are all related to good maintenance. So I talked about the bathtub curve. I said that most breakdowns occur in the first few phases of first few days or months or hours after maintenance. So while you're doing maintenance, the people who are entrusted with doing this on your machines should know what proper alignment is, should understand the importance of alignment. So bad alignment just stresses the equipment. It stresses the drive, it stresses the driven, it puts load on the bearings, it leads to failure. Balancing is the same thing. Again, stress on the bearing, stress on the shaft. So both alignment, balancing, and calibration, these are important things that need to be done, documented, understood, and studied while the machine is under maintenance.
Now tell us, how can vibration, noise, or temperature patterns signal upcoming breakdowns?
So, if you can hear noise and if you can see temperatures have increased on your equipment, some part has already failed. So, noise and temperature is the last phase before functional failure occurs. What you need to do is take some proactive steps. So monitor vibrations carefully. Vibrations could be the first step of recognizing that there is something faulty. And for that, you need to do some trends. So if you don't have the competence, arrange an external company who would measure vibrations along your equipment, see how they are growing. If you can see a trend of increasing vibrations before you can hear noise, before temperatures increase, if you can take corrective measures, you can save the bearing, you can save functional failure, and of course, catastrophic failure. So I'll talk of two types of failures. One is catastrophic. Machine has broken down, huge, big repairs. Functional failure, one part of it, say a bearing has gone, but there's always collateral damage. So something else is damaged because one part is broken down, and therefore I'd still say vibration, the first step, noise, temperature. Oh, you're already very late in trying to catch the failure.
Got it. Got it. Many MSMEs, Uday, run machines beyond recommended loads, which is a common pattern that we've seen across the board. How risky is that in the long term?
I'm seeing more and more SMEs understanding that you cannot flog the donkey beyond a certain limit. So we see that they are getting a little bit more careful about it. But overloading consistently means you're crossing limits. You're going to have the life exponentially reduced. You're going to have failures, and the cycle continues. And because you failed now, and because you're behind your production schedules, once the machine is up, you're now trying to overload it to meet your deadlines. It's a vicious cycle. So everything that bad maintenance does is creates more and more vicious cycles, which eventually is a losing proposition.
Understood. Now, Uday, how should factories approach preventive versus predictive maintenance with limited budgets?
So I have been working on predictive maintenance for decades. Today at Neptunus, we've possibly got the world's finest solutions for predictive maintenance. But let's take a halt here. Why predictive? So it is our belief, and at Neptunus we've proved it over the years, that preventive or time-based maintenance leaves too much money on the table. And we've been doing preventive maintenance. The world has been doing preventive maintenance for many, many years now, since the Industrial Revolution. It still hasn't prevented breakdowns. So we can conclude that preventive maintenance, despite being expensive, does not prevent breakdowns. And therefore, we go into what we call predictive or condition-based maintenance. That means that I will do maintenance whenever it is necessary. It may be earlier than what time-based maintenance is. It could be later. But I will now open my machine based on its condition. But to reach that, MSMEs budgets are a constraint. So what can we do? I'm saying, let us start with basics. Let us get into a culture of maintenance. Let us get into a culture where hygiene becomes important, where we are saying that we are going to focus on simple preventive measures. We are going to have low-cost condition monitoring checks. I don't want to invest great amount of money into an MSME, but I still want them to get into that routine, and then we can think about applying predictive technology on only critical machines. So this is the approach that I would take. Habits must change, culture must change. It has to be owner-driven. Take simple measures for most of your equipment, and only your critical equipment you should be willing to invest in predictive technology.
Understood. Tell us, are there any simple low-cost monitoring tools that MSMEs can easily adopt without heavy automation investments?
So, several. One is vibration monitoring. So if you don't have the capability to actually decipher or analyze vibrations, get a third party to do it. but follow a trend. Understand how your machines are behaving. So this is a very simple one. Invest in a good infrared thermometer. So the infrared thermometer will quickly tell you whether something is overheating without having to actually touch it. Very useful in electrical maintenance. If you open a panel and you use an infrared thermometer, you will see temperatures on contactors and electrical equipment that are starting to degrade. So very quick idea there. Then you can have leak detectors, ultrasonic machines. Importantly, if you've got machines that have oil in it, please send these regularly for sample testing to a lab outside, which will give you results which will tell you that there is extreme wear and tear, or whether your oil is degraded, or whether it's in good working condition. So oil analysis, oil testing, these are all simple, low-cost methods. Once again, and sorry if I keep stressing it, it's a question of habit, culture, and hygiene.
Moving on, Uday, tell our attendees, how does poor electrical maintenance contribute to mechanical failures?
So the two of them are related. So bad mechanical maintenance will cause electrical faults and vice versa. Understand one thing: if you take a simple motor, which is an electrical device, any imbalance in the electrical system, the first casualty is the rotating mechanical shaft. So anything that happens on the electrical side first starts affecting the shaft and the bearings, and then of course it escalates into short circuits, rotor bearings, etc. So we'll not ever talk of electrical or mechanical maintenance. What we should do is look at a machine as a whole and say, what are the parts that I need to keep this equipment going? So very often I hear industries talking of, oh, our electrical maintenance is good, mechanical is not. You can't really separate them. They're all entwined interlinked.
Now, Uday, help us understand the documentation part of it. According to you, what are the documentations or maintenance logs one should keep, or every industrial unit should maintain?
The biggest challenge for MSMEs, SMEs is tribal knowledge. So you got one guy who's working with you for maybe 8-10 years. You've entrusted him with maintenance. He knows what has happened. He knows when this machine makes this sound, this is what I need to do. Or he knows that if I do this, then this will happen or this will be correct. This guy leaves. And now, suddenly the organization does not know what to do. So tribal knowledge in MSMEs is a very, very big issue, not only in maintenance, but it goes into production, quality control, finance, marketing, almost every part. And therefore, I'm a big, big believer in documentation. So a personal example, we started, Neptunus was established 1996. We were ISO certified 1999, and initially we started doing the ISO as a marketing means or just to get that certificate up. Very quickly I realized, and the team realized, and the company realized that the stress on documentation was actually helping us build a robust organization. And so today at our company, documentation really is what helps us tide over most issues. So start off with simple things. You don't need expensive software. Excel sheets are good enough. So you can start with running hours. You can start with a machinery history. You can have a failure log. You can have a lubrication record, analysis reports, all in a nice single neat sheet. You can have alignment records. You can have vibration records. And finally, some clever guy, and today AI can do it in minutes, is to have a trend. So if you see a trend that your lube oil condition is deteriorating, your vibrations are increasing, you know there's something wrong there. And today, truly, if you can use simple things like ChatGPT or Cloud Coworker, you can put all this data here, you can get an analysis very, very easy. You don't need software. But as much documentation as you can maintain, the better it is for you.
Got it. Tell us, how can operators on the shop floor be trained to identify early failure symptoms?
So across industry and across countries, manpower and the quality of manpower is becoming a very big issue. So train we have to do, but I still believe today and stronger than before that we need to move on from people to technology. And therefore, any investment that you make in technology today, if you can have online monitoring of your critical machines, that could be your biggest help. Of course, we are talking about training. Today, you don't have people who stay on for 10 and 15 years. And I'm not saying that's right or wrong. There's aspiration of people, etc. But you keep training, you keep losing people. At Neptunus, I tell you, today we train people, and companies overseas on one call are happy to employ our people because they're so well trained. They don't even ask them for CVs. How many years at Neptunus? 3 years at Neptunus. Okay, you're fit to work with us. So we are trying to move away from being people dependent to technology dependent. That, in my mind, is the biggest lesson we need to learn. Of course, we need to teach them how to think of a machine as a living being, touch it, feel it, temperature, vibrations, etc. But it's a more unreliable solution than going in for technology.
And what role do you think does spare parts quality play in recurring machinery issues?
Aftermarket parts, as they're called, replacement parts, aren't necessarily poor quality. Okay. But how do you know which is a good quality replacement part and which is a bad quality part? And putting one part which is substandard into your machine can cause havoc. So 46 years after I've started working, I can say one thing, that I would never ever use a non-genuine spare part in a machine. It is just too risky. I would certainly go outside the original equipment manufacturer for service. And today I understand and believe that MSMEs can give you far better service than a large organization. So if you need to get your equipment serviced, if you call an SME, for example, if you call Neptunus, our CEO or our CEO this is always available to answer. You go to a larger organization and they're closed on a Friday, they're closed on a Saturday, there's a weekend, there's this, that, and you can never reach the top. Try reaching somebody in Amazon and you're struggling all the way because of contactability issues. So service, look at the best possible provider. Spare parts, please don't take a risk. Cheap in the short run, expensive in the long run is what aftermarket parts can do.
Now, moving on to my next question, Uday, tell us how can MSMEs avoid over maintaining machines and increasing unnecessary costs?
So there are two parts to this. A machine frequently breaks down. That's because of poor maintenance, and therefore interventions are more frequent. That means you're touching that machine more than you should. So if let's say a piece of equipment needs to run for 5,000 or 7,000 running hours, because of poor maintenance, it is breaking down at more frequent intervals. That by itself is over maintenance. Like we've discussed during this, you need to be careful in the first few hours, and therefore getting a good service provider who you trust, who can now assure you or who can take the best possible measures to prevent breakdowns after failures is one way that you can avoid using or what you call over maintenance. Over maintenance is nothing. See, nobody wants to open a machine which is running well. Nobody wants to tinker around. If your car is doing well, you don't want to take it to a service station and ask him to strip it apart and put it. You do it because you're forced to do it, and you're forced to do it because it's poorly maintained. So good maintenance, do it right the first time, use genuine spare parts, get a good service provider, and you'll see that your maintenance schedules can be very reliably elongated. You can have time between failures increasing, you can have time between overhauls increasing, overall bringing your cost down, increasing reliability, ensuring your customers are happy because your deliveries are on time. So it's one big circle that we need to look at.
Also, how should businesses prioritize maintenance across multiple machines with limited manpower?
So let's start by classifying equipment. So we look at, let's say, the most critical equipment. If this one shuts down, my entire production line is stopped. I'm going to be severely crippled. So those are my critical machines which need my attention. I'm going to focus on them. If required, I'm going to get technology, I'm going to get predictive maintenance, I'm going to put that on. Then I'll come to important ones. I can run my lines. I'll be stressed, but I can run my lines even if one of these machines is down. If it's not too expensive, I'll have a standby machine. So if one fails, I can use a standby. Easier said than done. There's a cost involved, but I can do this for pumps and motors, etc. And then other non-critical ones. So I'd pay lesser attention to the non-critical ones. So greatest attention, critical ones, I put in technology, put in sensors, put whatever is needed to keep them running. Important ones, I try and have standby equipment. And then the non-critical equipment, of course, is something that I hope will not break down, but I'd not spend too much bandwidth on them. This is how I would prioritize maintenance with limited resources. And all MSMEs have limited resources. Unfortunately, if we had limitless resources, we would have been bigger enterprises.
True, that's true. Can better vendor selection or OEM consumption, coordination rather, reduce breakdown frequency?
Yes, but it has to be an overall part of your approach to maintenance. So OEMs generally, and this is a fact. So OEMs generally want to push more spare parts. OEMs don't make so much money in selling new equipment as they make in selling new spare parts. So an OEM is always going to push you into getting more spares from them, and that is why I say that look for a good alternate, good for a good service provider. And there are so many around us here who are not pushing you for spare parts, who are now saying that we don't need to change this. This is still in good condition. This is within limits. So look at vendors, and there are several of them today. There are some extremely good vendors for every machine today. Good experience, focused on customer delight. Look at these guys for your maintenance. Go back to your OEM for spare parts. But both these together can make maintenance much, much easier.
Got it. Tell us, how does downtime in one machine cascade into production losses across the plant?
See, once again, we are an SME. We have got maybe one or two lines, and these lines are designed to run at 100% to give you the output. So we are all struggling for time. Any one machine, and we talked of critical, we talked of important, we talked of non-critical. Any critical machine that breaks down will finally force you to stop your production lines. So when we talked of critical, important, and non-critical, one of the other reasons, of course, is to find out and understand what each machine's breakdown can do to the entire production line. Finally, our intention is to produce, our intention is to supply, our intention is to have a production line which is busy and which meets customer demands. So your sales guy should never be complaining that I'm selling but you cannot supply. And therefore, downtime can easily cascade. When one machine goes down, the rest of them. So if A depends on B, depends on C, and if C breaks down, the entire other line is useless. And the old adage that says, you lost a kingdom for want of a shoe nail or a horse nail, it's really very true. So simple things, simple equipment can really render big machines useless. That's something that we need to take care of.
Piece of advice from you there. If an MSME wants to start improving reliability from tomorrow, what are the first 3 steps that they should take?
So I've said this, I'll say it one more time: hygiene. So make that a habit, make that a culture. So very interestingly, when I went out to sea and I started working, one of the most everlasting impressions on me was how the Germans worked. Before they started work, they laid out their tools well. At the end of the day, each guy, no matter how senior he was, he cleaned his tools. There was never dirt on the equipment that they worked with. They took great pride. The Japanese are the same. That is something that we need to bring in our culture. So if we can have hygiene as a very important factor, as a culture building exercise within our organization, we do a lot of good to our maintenance. Every breakdown should become a learning opportunity. If we don't learn from that, then it's one of the questions you ask me, why do the same things happen again and again? The same things happen again and again because we don't learn. Lubrication, we said, is a very important part. Pay great attention to your oil and grease. Please treat it as the most important raw material that's getting into your equipment. Do not take that lightly. And finally, if you can keep documentation, trends, records to simple things that will force you not to ignore warning signs. So if your chest starts paining, you go to a doctor on time. But if your equipment is screaming, you still want to run it till it breaks down. Doesn't make much sense. So these are some of the simple things. And we work with a lot of industry. We work with bigger ones, smaller ones. Today we are working with a lot of large platforms, oil rigs, etc. And our simple mission is, how can we prevent breakdown? So Neptunus has been at it for 30 years now. Our mission is reliability. Our whole purpose is, can we make machines more reliable?
That brings us to the end of today's discussion. Thank you so much, Uday, for being with us and for sharing your detailed insights on such an important and critical topic, which is preventing breakdowns in industrial machinery. Thank you so much. Your more than 4 decades of experience, I'm sure, adds a lot of value to our attendees who are online and watching you live. Thank you.
Thank you, Amrita. It was a pleasure being here, and I'm happy to help anybody without, I'm not bringing in cost or money into the picture, but I'm happy to help MSMEs. If anybody wants any help or whatever, I'm free to reach out to you. Eventually, I understand the pains of our MSMEs. So it was a pleasure being here, Amrita. Thank you for inviting me.
Thank you so much, Uday. It was lovely having you. For our attendees who are online, if you've missed any part of the current episode, if you'd like to view this episode once again, please go on YouTube, type JSW1 MSME, and find all our episodes uploaded there. Thank you, Uday. Bye-bye.
Thank you. Bye-bye.